Hello and welcome. This is going to be our lecture video for November 4th through 5th. Go ahead and get out your notes. Let's get started. I wanted to practice foiling really quick at the top of this lesson. It's going to help us with factoring later on. So let's just review how to simplify this expression here. So in between these two parentheses, there's multiplication there. Inside the parentheses are not like terms, so I can't just combine what's inside. So I need to do this multiplication, but the parentheses are getting in the way, and our way around it is to FOIL. And when we FOIL, it essentially just makes sure that every term in the first one gets multiplied to every term in the second expression. We get every combination possible here. When I do my first 2x times x times x becomes an x squared, and that 2 is just sort of along for the ride. When I do my outside, 2x times negative 4 becomes a negative 8x. Inside is 3 times x, so plus 3x, and then last 3 times a negative 4 is a negative 12. Now it's very common for these two middle terms to be like terms, so we're not done simplifying until we combine them, and we get something that looks like this. All right, try this next one on your own. I'll just put up my work. And I get my final answer, negative 4x squared minus 4x plus 8. You might have been wondering about what to do with that negative in the front. You can distribute it at the beginning or at the very end. I like to distribute it at the end, so I'm not dealing with multiplying by too many negatives. It's not the end of the world to multiply by negatives, but save myself a little bit of work by distributing that negative at the end. Okay, goal for today is to be able to solve quadratic equations by factoring. Why factoring is an essential skill for taking apart polynomial equations. You're going to need it for the rest of this unit, our next unit, several topics next semester, and if you go on to Trig pre-calc, you'll be expected to know factoring like the back of your hand on day one. So we got to be good at factoring, and you probably saw it in Algebra 1, so you might already be pretty darn good at factoring. But we will see factoring by grouping in a little bit, and that is pretty tricky. Okay, so this is a quadratic. We don't see the squared, but if I was to FOIL this, I would pick up the x squared when I multiplied my first terms. The x times x, I would get an x squared. Each of these pieces of this equation within the parentheses, these are called the factors. All right, and just one would be a factor. And then the numerical part of the factor is called the root, but you have to flip its sign. So negative a is a root. So the whole thing with the parentheses and the x is called a factor. Just the numerical part, which is being represented with a variable right now, but normally that's a number right there, is the root, also known as a zero. We use a lot of this terminology interchangeably. So copy that down. There's anything else I want to say about that? Okay, how to factor. Step 1 is factor out a leading coefficient if needed. Here, our leading coefficient is 1, so we don't have to factor it out. But if it was a 2, what we'd want to do is divide every single term by 2 so that we could just write a 2 out in front, rewrite our quadratic expression, and then just factor the quadratic expression, keeping the 2 out in front. All right, so that was kind of step 1. Step 2 is, this is how I like to do it. I like to actually write out the structure of factored form. So I make a little thing that looks like this. I write out the x's in the parentheses so I don't even have to think about them as I try to fill in these two constants. All right, and then in step 3, you ask yourself, what two numbers multiply to be 6 and add to be 5? And it's always that 6 is just a 6 because it's a 6 in this problem. That's always your last term. And this 5 is always just your middle coefficient. All right, so can we answer that question? What two numbers multiply to be 6 and add to be 5? Well, the correct answer is 3 and 2, so I would just fill into my structure up here a positive 3 and a positive 2. And then you can double check by foiling. Oh, my tablet just died, so I'm going to take a quick pause to grab a new one. Okay, I'm back, and what I was saying is you want to double check this by foiling it back out and making sure you get back to that quadratic there. All right, here's another one for you to practice. So no leading coefficient. So I'm going to create the structure here, and I ask myself, what two numbers multiply to be 6 but add to be -7? Well, because that's a negative in the middle, I know that these actually, I'm going to have at least one negative, but since it's a positive at the end, it's going to have to be 2 negatives so that they multiply to be a positive. And then to get all the way to 7, the only way I can think to do it is with a 6 and a 1. Those now multiply to be a positive 6, but add to be a -7. All right, let's try it again. No leading coefficient, so I just create the structure. What two numbers multiply to be -6, but add to be +1? There's an invisible 1 there. Multiply to be -6, but add to be 1. It's a +3 and a -2. All right, that way they add up to be that +1, multiply to be -6. Let's try one more. Create the structure, no leading coefficient to multiply away. Notice this example uses s as the variable, so I should make sure I don't just swap it out for an x. I gotta stick with s. Two numbers that multiply to be -35 but add to be -2. Well, I know 35 is the product of 7 and 5. That's like the only two numbers that multiply to be 35. So I gotta figure out how to combine a 7 and a 5 to be a -2. And I think a -7 and a +5 will do it, and those multiply to be -35, and they add to be -2. So yeah, you got to kind of practice with this. When you see numbers like 35, you should immediately know that that is 7 times 5. It's the only way to split that apart, other than 1 and 35. You'll start to recognize things like that. Okay, let's move on to a different topic. Can you solve this in your head? All right, did you say that the answer was 0? How do we know? Because there's a 0 in here and it's all multiplication. So anytime you insert a 0 into some multiplication, it makes the whole thing equal to 0. That leads us to something called the zero product property. Let's copy this down. All right. If when multiplying, one of the terms is 0, the product will be 0. All right, that's all you have to write down for this. But the opposite is true as well. If you know that the product is 0, you can say for certain that one of the terms must have been 0. So you can go the other direction with this as well. There has to be a 0 on both sides. All right, now we can use the zero product property, which we often abbreviate ZPP, to solve an equation like this. Here we have two things being multiplied. Those things in this case are expressions, but they're glued together with those parentheses. So if either expression is 0, the equation will be true. And since we're looking for values that make this equation true, we'll have solved the equation. So I've got two things being multiplied, hidden multiplication in between. If either of them is equal to 0, then their product is 0. We've got a 0 on this other side, so the equation will balance. Because that's true, I can take each of those factors and set it equal to 0 by itself. So this is the zero product property in action. I'm saying if either of these is 0, the whole thing's 0 and the equation's true. All right, let's go ahead and solve both sides. And we get x equals -4/3. And x equals 2. So we have two answers. And that's okay. With quadratics, we normally do get two answers. So two different values for x that make this equation true. All right. So here you've got a quadratic in standard form set equal to 0. So we can solve this now by using factoring. We'll factor the left-hand side and then use the zero product property to set both of the factors equal to 0 and then solve. So let's create the structure of factored form. Ask ourselves what two numbers multiply to be -10 but add to be 3. Like actually say that full sentence in your head, and it really helps you come up with it. So two numbers that multiply to be -10 but add to be 3. Multiply to -10, add to 3, I'm thinking it's got to be a +5 and a -2. That way they'll multiply to be a -10, but add to be 3. Okay, and now by the zero product property, I'm going to take each of these factors and individually set it equal to 0. You can show your work here by saying we were allowed to do this by the ZPP. And on the left side, we get x equals 5. That's a valid answer. And on the right side, we get x equals 2 as another valid answer. All right, so two answers. You got to get them both to get the points. Here we've got another one. But for the first time, we see a leading coefficient. But instead of factoring out that 3, because we have an equal sign, we can play off the equal sign and just divide both sides by 3. And I wouldn't do this if every single coefficient wasn't divisible by 3, but they all are. So here we get x squared plus 6x plus 9 equals 0 divided by anything is 0. And then this is a whole lot easier to factor. All right, in your head, you should be saying, what two numbers multiply to be 9 but add to be 6? Well, a 3 and a 3. And then by the ZPP, I can set these equal to 0. You'll notice they're the exact same, so I don't really have to do this twice, but I'm going to anyway. All right, and so we get x equals -3 and x equals -3. You might just say, oh, so this only has one answer. Well, there's a way of thinking about math that these actually do count as two answers. They're just two answers at the same spot. and we call that a double zero. So it's a 0, 1 is that's how we solved it, but also if we were to like graph just the left-hand side, this is where it's going to be crossing the x-axis. And so it's like it's crossing twice at one point. If we start thinking about this as two separate answers, that's going to help something called the fundamental theorem of algebra work a lot better, because we won't have to be making exceptions to the rules. We'll just say, I mean, it's sort of an exception to the rule, but we've got two answers at the same spot. It's also called a multiplicity. You'll see that you'll get x equals -3 with a multiplicity of 2. It's another way to refer to a double zero. And yes, triple zeros and quadruple zeros are also possible, but we'll get into that next unit. Okay, so here I've got another one. It's equal to 0, but I can't divide everything by 10. 14 and 4 are not divisible by 10. They are divisible by 2, so I can make this a little bit simpler and make this 5x squared minus 7x plus 2 equals 0. But I can't quite get this down to 1. I could divide everything by 5, but then I'm dealing with decimals. So what I want to do is when I go to create the structure, I'm going to put a 5x and an x in there. And that way when I multiply my first terms, I get a 5x squared. And there's no other way to do it because 5 is prime, so you can only reach it by multiplying a 5x and an x to get a 5x squared. Now I need these two numbers to multiply to be 2. But the trick is they don't have to add to be -7 because one of them is going to get multiplied by 5 for this 5 right here. But there's not that many numbers that multiply to be a 2, and then I see this negative here. I know that they're going to have to be both negative, so I've got a -2 and a -1. I just have to pick which side to put them on. And the way that I'm thinking it's going to work out is a -2 here and a -1 over there. Now off to the side, let's actually FOIL this and see if we get back this expression here. We'll get a 5x squared for doing our first terms. Outside will give us a minus 5x. Inside will give us a minus 2x, and last will give us a plus 2. We do indeed recover our original expression, meaning that we factored it correctly. And now we can do the last part of this, which is solving by using the ZPP. So we've got 5x minus 2 equals 0. X minus 1 equals 0. That's by the ZPP. Add 2 to both sides. 5x equals 2. Divide by 5, divide by 5. X equals 2/5. Plus 1, x equals 1. Okay, but the guess and check method, we don't want to be doing that for everything. So we do need to learn this new technique, which is called factoring by grouping. And here we've got a quadratic that would be kind of difficult to factor by guess and check. One is we don't even know what to put in that first spot because it could be a 1x and a 9x, or it could be a 3x and a 3x. Both of those would get us our 9x squared back. And then -80 has a ton of factors. So we'd be testing a lot of different things, 2 and 40, 8 and 10, 20 and 4, and there's lots of others. So we got to do factoring by grouping. First thing is multiply A and C off to the side. So 9 times a -80 is a -720. All right, now you need to split -720 into two factors. That add to 6. And that 6 is going to just be the middle coefficient. All right, and then this takes some practice to get good at it. One thing I like to do is just take the square root of this number to get a good starting spot. So the square root of 720 is 26.8. So I can start picking numbers near 26.8 until I find two numbers that multiply to be 720. Also 720 is even, so you know one of the numbers is going to be even. So an even number near 26, I'd probably go with 24 as my first guess, and you'd get it right off the bat. So 720 divided by 24 equals 30, meaning 30 times 24 equals 720. And this is good because the gap between them is 6. I just have to make the 24 negative, and now when I add them together, I'll get a positive 6. When I multiply them, I'll get my negative 720. Okay, so this scratch work off the side tells you how to split up that middle term. Instead of a 6x, I want to rewrite this as 9x squared minus 24x plus 30x minus 80. And actually, this is where it gets a little bit tricky because you could also put the 30x over on this side and the negative 24 on that side. Let me just think for a second. I think that's what I want to do here. And I sort of just did the next step in my head. For you, as you're just practicing this for the first time, you might just have to do it both ways to see which one works. Okay, so what did we just do? Let's write down what we just did. So now we want to split the middle term into two terms with the coefficients you just found. All right, now what's next? We add parentheses around the first two terms and the last two terms. And you might have to put a little plus in between so it doesn't look like you're multiplying them. So this is something about parentheses, is that as long as you're not changing the order of operations, you can kind of just throw parentheses wherever you want. So we want to group, this is why it's called factoring by grouping, the first two and last two terms. All right, now from those groups, you want to take out the greatest common factor. And hopefully, if you do this right, it's going to leave behind the same factor. So here I can take out a 3x, leaving behind a 3x plus 10. And from this factor here, I can take out a negative 8, leaving behind a 3x plus 10. Like that, we've got matching factors. So, okay, again, let's write what we just did. Take out the greatest common factor of both groups. All right, and now we want to regroup. So the 3x and the negative 8, they become their own factors. So 3x minus 8. And then you just keep one copy of this 3x plus 10. And I just call this regrouping. Oh, and then only keep one copy of the repeated factor. And so you could think of this step up here as an intermediate to distributing for this step down here. Instead of foiling, what you could do is distribute the 3x to this expression first, then distribute the negative 8, and you'd get this intermediate step to foiling right here. But if you look at what we've done is we have factored this. This is now factored form. So we're done. All right, and this is a process that just does take a lot of practice to get good at it. Here, let's solve this problem here. It's going to require factoring by grouping. So we want to get it set equal to 0 so that we can use the zero product property. So it's really important that we move this 3a squared over to this side. So we get everything set equal to 0. Now we got 14a squared plus 33a plus 18 equals 0. All right. Is there a common factor to be canceled out here? It doesn't look like it. The only factors for 14 are 2 and 7, and 7 does not go into either of these. Neither does 2. So off to the side, let's multiply 14 times 18. And we get 252. Now I've got to split that into two numbers that add up to be 33. Well, here we've got kind of a starting place right here, 14 times 18. Those add up to be 32, so we're close. Let's try splitting up this 252. Let's divide it by, I'm just going to take a guess of 12. And I get 21, so 12 and 21, that does add up to 33. So now I'm going to split up this 33 into a 12 and a 21, and I'm going to put the 21 on the left because it shares a common factor with 14, and I think that's going to work. So now I've got 14a squared plus 21a plus 12a plus 18 equals 0. Now parentheses are free, so I'm just going to add them around these two groups here, then take out the greatest common factor, which is a 7a from here, leaving behind a 2a plus 3, and a 6 from here, leaving behind a 2a plus 3. This is still equal to 0. Regroup, I get a 7a plus 6 as one factor and a 2a plus 3 as the other factor equals 0. And now we're ready to use the zero product property to set these individually equal to 0. 7a plus 6 equals 0 and 2a plus 3 equals 0. And what do I get? 7a equals negative 6 divided by 7 divided by 7. A equals negative 6 sevenths. And a equals negative 3 halves. Box them both. You can plug them back into double check. Might be a little bit hard since they're fractions, but you still could do it. And we're done. Okay. Other ways to solve equations with quadratics. So if there's not a middle term, you don't have to factor this. Instead, move everything other than the quadratic to one side and then just take a square root of both sides. So here I could just add 6 to both sides. Now I've got 9n squared equals 9. Divide both sides by 9. N squared equals 1. Take the square root, take the square root. And here, this is kind of tricky. The square root of 1 is both positive and negative 1. Because 1 times 1 equals 1, but also negative 1 times negative 1 equals 1. So that's where you get your two answers. So this is for equations with no b term. All right, let's try it on this one. So I add 5, I get 64n squared equals 25. Divide by 64, divide by 64. I get n squared equals, and then leave this as a fraction, 25 over 64. Let's take the square root of both sides. Now I get n equals, and I can distribute that square root to the top and the bottom of this fraction, the square root of 25 over the square root of 64, which equals 5 over 8. And don't forget your little plus or minus in front. I think we can skip this one, and we'll call that good. For this lecture video, I'll embed a few more questions here, and have a good rest of your day.